Myself Satish, and I am going to teach one of the chapter that is in science. Okay, so the chapter that has been selected, it is metals and non-metals. See, you all know that science, it has three main branches: physics, chemistry and biology. Okay, so in general science so what is the definition we can give for science? Science, it is the systematic study of knowledge. Okay, so science is the systematic study of knowledge. See, whatever we learn in science, it is facts. Okay, science is nothing but facts, and those facts, they are always studied in a systematic way. So that branch which deals with systematic study of facts, which is nothing but knowledge, is science. So all topics what you study in physics, chemistry and biology, they are about facts only. So in today's class, I selected a chemistry lesson, that is metals and non-metals. First, let us know what is actually chemistry. What things we study in chemistry? See, all of you know that in our surroundings we have hundreds of things that are present. So all those things which are present around us can be classified into two types. Living things and non-living things. So things which have life, they are called living things, and one of the branch of science which deals with study of living things, it is biology. And similarly, the things which does not have life, they are termed as non-living things. Okay, so chemistry deals with the study of both living things and non-living things. See, scientists, they have called all the things which are existing around us, whether it is a living thing or non-living thing, including ourselves, as matter. So chemistry deals with study of matter. Okay, so from the smallest particle of a dust to the farthest star, everything is matter. See, there is one famous definition for matter, that is anything that occupies space and as mass is called as matter. See, according to the definition, so two important terms that are used here. One is space and another is mass. So anything which occupies space and that has mass is called as matter. Okay. So according to this definition, everything that is present around us, including ourselves, can be called as matter. So from the smallest particle of a dust to the farthest star, everything is matter only. Okay. For example, book is matter. So how we can say that book is matter? Because book occupies space. See? So this book is occupying space and it has weight, that is mass. So we can call the book as matter. See, you know that matter exists in three different states. Some matter are solids, some matter are liquids, and some of them are gases. See, it is very easy to prove that solids and liquids are matter because they have physical existence and they are visible. Similarly, gases, they are also existing, but we cannot see gas. For example, in this room, air is existing, but I cannot see air, but I can feel the air. So how we can prove that gases are matter? Simple experiment. When we say gas is a matter, then same rule is applied for that also. That means it should occupy space and it should have mass. So there is a simple experiment, I think all of you have studied, to show that air is a matter. Balloon experiment. So take a balloon and go on filling air. Balloon will be get inflated. That means air, which is actually responsible for the inflation of balloon, it is occupying space. So inflated balloon where air is present, that shows that it occupies space. Take an empty balloon and balloon filled with air. Weigh them on a scale. You can see that balloon filled with air will be having more mass than empty balloon. See, this is a simple experiment by which we can say that is gases are also matter. So matter exists in three different states: solids, liquids and gases. So chemistry subject deals with study of that is matter. So it is a branch of science which deals with study of that is matter. Okay. Now let me write the definition of chemistry and then we can move on to that is the chapter metals and non-metals. So it is a branch of science deals with study of matter. Okay. So next question is, matter is made up of what? Okay. For example, let us take water. Water is a matter. So water contains what? I think all of you know that water is a substance which is having molecular formula H2O. That means in water we have two elements. One is hydrogen and another is oxygen. Similarly, if you take common salt, common salt formula is NaCl, sodium chloride. So it is made up of two elements. One is sodium and another is chlorine. Similarly, sugar. Sugar formula is C12H22O11. So it is made up of carbon, hydrogen and oxygen. Okay, see, these are the very common substances. We can take the example. So water contains hydrogen and oxygen, common salt contains sodium and chlorine, sugar contains carbon, hydrogen and oxygen. So by this we can say that if we take any matter, it is made up of, that is, elements. So elements are the building blocks of matter. So all matter is made up of, that is, elements. So question is, what is an element? See, element is a pure substance. Element is a pure substance which cannot be synthesized or cannot be decomposed. Yes, cannot be synthesized from simpler substances and cannot be decomposed into further simpler substances. By any chemical methods. It is called as element. Okay. So element is a pure substance which cannot be synthesized from simpler substances and cannot be decomposed into further simpler substances by any type of chemical reactions. Such substances are called as elements. See, all of you know that, I think all of you have seen a chart related to chemistry, chart of elements, which is called periodic table, and there you can see 118 elements. So that means the number of elements which are known at present. It is 118. So 118 elements are known at present, and out of these 118 elements, "92 elements are called natural elements." That is from hydrogen which is the first element, to uranium. This is first element, this is 92nd element. So from hydrogen to uranium, that is the 92 elements which are there, they are found in nature. Elements which comes after uranium, they are called as synthetic elements. Okay, so uranium, after uranium, that is from 93 up to 118, they are called as synthetic elements or man-made elements. That means they are prepared in lab through chemical reactions. Whereas if you take 92 elements, they are found in nature. Okay, so 118 elements, they are classified into two types based on their occurrence. Similarly, in order to study about elements in detail, we all know that elements undergo chemical combination in all possible ways, results in the formation of compounds. For example, if you take water, how it has been formed? It has been formed by the combination of hydrogen and oxygen. Common salt, how it has been formed? By the combination of sodium and chlorine. Sugar, it is formed by the combination of carbon, hydrogen and oxygen. So if you take any matter into consideration, it is formed by the combination of one or the other, that is elements only. That's why we can say elements are the building blocks of matter. So one of the important characteristic property of element is chemical combination. They can undergo chemical combination in all possible ways, and that has resulted in the existence of huge number of, that is, things around us. So why elements undergo chemical combination? What is the reason? Why compounds have been formed? See, in order to understand about all these facts, that is detail, we have to understand about elements. So we have to learn in detail about elements. That is why scientists, they have thought of classification of elements. Okay, so we know that classification is very much essential in all branches of science. Classification is nothing but grouping. Grouping the things which are having similarities is nothing but classification. So in chemistry, we have classification of elements. See, earlier only very few elements were known, that is towards the end of 18th century, around 30 to 40 elements were known. But as the time passed, number of elements went on increasing, and today we have 118 elements. So in order to study the elements and compounds which have been formed by elements, so classification is very much essential. See, for classification there must be a basis. Without basis, classification is not possible. Okay, so what basis can be used for the classification of elements? That problem arose. See, for the first time, the classification of elements, it was given by Anthony Lavoisier, known as father of chemistry. So Anthony Lavoisier, he proposed a classification for the existing elements at that time, and there he considered physical and chemical properties of elements for the classification. So for the first time, Anthony Lavoisier, based on physical and chemical properties of elements, he gave a classification, and there he classified all the known elements into two broad categories: metals and non-metals. So first type of classification of elements, it was given by Anthony Lavoisier based on physical and chemical properties. Okay. So today also we are following the classification given by Anthony Lavoisier. So now we have to understand what differences we can see with respect to physical and chemical properties of metals. Okay. So first let us take about physical properties. See, based on physical properties, it is possible to say an element is a metal or non-metal. Okay. Yes. Here you can see that is metals and non-metals, important physical properties of metals. So, physical state. All the metals except mercury exist in solid state at room temperature. See here. So some examples for metals they have mentioned here, that is copper, iron, aluminium, sodium. Many examples you can give: gold, silver. They are all metals. So what are the physical properties of metals? First is physical state. Okay. So all the metals except mercury, they exist in solid state. Metals are solids at room temperature except mercury. Very important. So except mercury. Mercury is the liquid metal. So in competitive exams, definitely you can expect question related to exceptions. So the metal which exists in liquid state at room temperature, it is mercury. So like that you come across many such exceptions, so you have to learn. Then luster. What is actually luster? Luster is shiny appearance of a substance. Shiny appearance of a substance is called as luster. And metals, they have a characteristic luster called metallic luster. I think you have seen that some metals, they are used for making ornaments. For example, gold metal, platinum metal, silver metal, they are used for making jewelries. So one important reason for using such metals for making ornaments, it is because of their shiny appearance, that is metallic luster. So generally metals, they have shiny appearance, and which is known as luster. Okay. Then next is very important property, malleability. Okay. So what is actually malleability? The process of or the property of metals where they can be beaten or hammered into thin sheets without breaking. Is called as malleability. See, because of malleability only, metals are used for many purposes in our day-to-day life. Okay. See, metals, they can be beaten or hammered into thin sheets, and by virtue of that property, that is, we can use metals for many purposes. See, in almost all spheres of our life, we use metals for different purposes, and there the properties of metals which are actually responsible for their uses in our day-to-day life. So malleability is one such important property, characteristic property of metals. By virtue of it, metals can be used for many purposes. See, if you take malleability, some metals, they are more malleable, whereas some metals are less malleable. For example, if you take silver, silver, it is the most malleable metal. Okay, so remember, most malleable metal is silver. Similarly, if you take zinc, it is non-malleable. Even though it is metal, it cannot be hammered into thin sheet. Suppose if it is hammered, it break away into pieces. It is almost brittle in nature. Okay. Common salt, I think you have seen. Suppose if you break common salt, what happens? It actually splits into many pieces. Same thing, zinc metal, when it is beaten or hammered, it breaks into pieces. It will not be get converted into thin sheets. So there are some exceptions we can give for all properties. Okay, there is always some exception we can expect with respect to properties. So by considering that exception, we cannot say that it is not a metal. So with respect to many other properties, zinc resembles, that is, metallic properties, that's why it is considered as a metal. Okay, so this is another important property, physical property of metals. Similarly, next is ductility. Again, another important property. Ductility. So the property of metals where they can be drawn into thin wires. So this property of metals, it is called as ductility. Okay, I think all of you have seen copper wire. Similarly, aluminium wire, iron wire, all of you have seen. Similarly, if you take silver or gold, chains you have seen. Okay, so metals, they can be drawn into thin wires, and that property is called as ductility. And again same, silver is the most ductile metal. Okay. See, if you take 1 gram of silver, it can be drawn into nearly 200 meters. Just 1 gram of silver can be drawn into such a long wire. So just you can imagine, that is how it possesses that property, that is ductility. Okay. So malleability and ductility, they are two important properties of metals. By virtue of them, metals are used for many purposes. Okay. Then next property, it is conductivity. So what is actually conductivity? See, conductivity, it is of two types. One is called thermal conductivity and second is called electrical conductivity. So metals, they show two types of conductivities. One is called thermal conductivity and another is electrical conductivity. So what is thermal conductivity? Thermal conductivity is nothing but conduction of heat. So electrical conductivity is nothing but conduction of electric current. So metals, they show both these properties. That's why we can say metals are good conductors of heat and electricity. Suppose if two elements are given and if you are asked to identify which one is a metal. Suppose you have given, let us say, graphite, which is let us take the example of solid element. Let us take the example of silicon. Okay. Or any other non-metal we can take, sulfur or phosphorus, or best is coal, which is carbon. Okay. So if you take carbon, that is coal, and if you take, say, copper metal. So you are given two substances, one is coal, that is carbon, and another is copper metal. And if you are asked to identify which substance is metal and which substance is non-metal, definitely we can go for electrical conductivity. Copper metal conducts electricity, whereas coal does not conduct electricity. By that we can say copper is metal, whereas coal is non-metal, which is carbon. Okay. Except graphite conducts electricity, that's because of different reason, it's an exception in case of non-metals. But in general, non-metals do not conduct electricity, whereas metals conduct electricity. Similarly, thermal conductivity and electrical conductivity, both are very important characteristic physical properties of metals. Okay. So again same, which metal is the best conductor? See, the best conductor is again silver. So best conductor it is silver. Similarly, heat. Conduction of heat also very important. So silver is the best conductor of heat as well as electricity. Thermal conductivity and electrical conductivity. Silver is the best conductor. Okay. So that is one more important physical property related to metals. Then hardness. See, generally metals are hard in nature. You all know that. You have seen many metals, iron, copper, aluminium, they have hardness. Whereas if you take non-metals into consideration, they are soft in nature. Okay. So here one important exception is there with respect to hardness. So generally metals are hard in nature except sodium and potassium. Sodium symbol is Na, potassium, that is K. So sodium and potassium, they are soft metals. See, sodium metal, I think you have seen some experiments, I think in your schools have been shown by using sodium metal. It is a very soft metal and it is preserved in kerosene. So why actually it is preserved in kerosene? Because it is highly reactive in nature. If sodium metal is exposed to air, what may happen? It can combine with components of air like oxygen, water, carbon dioxide, and it will be get converted into some other product. So that's why sodium metal is stored in kerosene. It is highly reactive metal and it is a very soft metal. Sodium metal can be cut with knife just like a cake. So I think all of you have seen how we can cut cake. Easily we can cut cake with the help of knife. In the same way, we can cut sodium metal or potassium metal by using a knife. That shows that they are soft metals. Okay. So again, exception. So remember the exceptions very well, because based on exceptions only, normally you can expect questions in competitive exams. Okay. So that is one more important physical property. Similarly, next is melting points and boiling points. So what is actually melting point? See, melting point, it is the temperature at which a solid changes into liquid. So it is called as melting point. Temperature at which solid changes into liquid is called melting point of the substance. I think all of you know that ice, which is a solid form of water, changes into liquid water at 0 degrees Celsius. That means 0 degrees Celsius is the melting point of ice. Similarly, if we take metals into consideration, metals are solids and on heating, metals will be get converted into, that is solid metals will be get converted into liquid metals. So the temperature at which a solid metal changes into liquid metal, it is nothing but melting point of the metal. So generally, melting point of metals is high. So metals have high melting point. That means in order to change solid form of metal into liquid form of metal, high temperature is required. Okay. So actually melting point of substances, it can be used to compare the force of attraction between particles. See, we know that if you take matter is made up of particles. So matter is made up of particles and particles may be atoms, molecules or ions. So in case of metals, metal atoms are present and between metal atoms, that is force of attraction is strong. For example, say you have given wax, candle wax and iron metal. So, and if you are asked to say which one is having higher melting point and which one is having lower melting point, easily we can say. If you take wax onto flame, it easily melts. Whereas if you hold iron wire in a flame for very long time, it will not melt. So, melting point actually indicates the force of attraction between particles. So, in case of metals, the force of attraction between metal atoms is quite high. That is why very high temperature is required for converting solid metal into liquid metal. So, which metal is having highest melting point? It is tungsten. Symbol is W. Okay. Tungsten metal is the metal with highest melting point. Think you have seen incandescent bulbs. So, there one filament will be used, and when that filament is get heated, it produces light. See, actually that filament is tungsten filament. So, why actually in incandescent bulb tungsten filament is used? Because of its high melting point. So, this is having high melting point. Similarly, metal with low melting point is mercury. Hg. Mercury is a liquid. That's why its melting point is very low. At room temperature itself, it exists as liquid. So, mercury metal, it is having low melting point. See, just like melting point, boiling point also can be considered for metals. See, generally metals, they have high boiling points. Again, what is boiling point? See, for solids we take melting point. For liquids we take boiling point. The temperature at which liquid changes into gas, it is called as boiling point. So, generally all metals, they have very high melting points and boiling points, whereas non-metals, they will be having low melting points and boiling points. Okay. Yes. See, these are the important physical properties of metals. Similarly, when we come to non-metals, so if you take physical state of non-metals, non-metals may be solids, liquids or gases. Suppose if you take solids, carbon is solid, sulfur is solid, iodine is solid. Similarly, liquid, there is only one liquid metal, that is bromine. Bromine is the only liquid non-metal, and remaining all are gases. Hydrogen, oxygen, nitrogen, they are all gases. So, if you take 118 elements into consideration, only 22 elements does not show metallic properties, which are considered as non-metals. Remaining all other elements are metals only. 80% of elements are metals, Only 20% of elements are non-metals. That means which do not show metallic properties. So when we take physical state of non-metals into consideration, they may exist as solids or liquids or gases, whereas metals, all of them are solids at room temperature except mercury. Then luster. See, metals have shiny appearance, that is metallic luster, whereas non-metals, they have dull luster. That means they have dull appearance. I think you have seen charcoal or coal. So if you observe charcoal or coal, it is having dull appearance and which is called as dull luster. Then malleability and ductility. Non-metals, they are non-malleable and non-ductile. That means they cannot be changed into thin sheets or thin wires. So non-metals, they are non-malleable and non-ductile. Okay. Then conductivity. Non-metals are bad conductors of heat and electricity. Except, very important, in many competitive exams, they will ask non-metal which conducts electricity, except graphite. Graphite is carbon which is good conductor of electricity. Okay, so that one you remember, graphite. Then hardness, when we take, see, metals are very hard, whereas non-metals, they are soft in nature. See, most of the non-metals are gases and one is a liquid. When we take solid non-metals into consideration, they are not as hard as metals. And here is one exception again, that is diamond. Diamond is carbon which is hard in nature. It is the hardest naturally occurring substance. Okay. Then melting points and boiling points. Metals have high melting points and high boiling points, whereas non-metals have low melting points and boiling points. Okay. So by considering physical properties of elements, it is possible to classify them as metals and non-metals. Okay. So if any element shows majority of properties, then based on that we can say whether it is a metal or non-metal. So by considering physical properties of elements, it is possible to say whether it is a metal or non-metal. See, this is how the first type of classification was given with respect to elements by Anthony Lavoisier. See, not only considering physical properties, we can also consider chemical properties to distinguish metals from non-metals. So in the next meet, we can learn about the chemical properties of, that is, metals and non-metals. So based on what chemical properties it is possible to distinguish metals and non-metals, that we can, that is, discuss. I hope all of you have that is understood the important concepts what we have learnt with respect to physical properties of metals and non-metals. Hope all of you will join to the coaching class, and I think definitely we will help you to that is come with higher success in competitive exams. We are all very well experienced teachers. So if you join to the class, definitely you will be having that is more knowledge about the subject, and you will be trained to crack competitive exams. So in detail we are going to clear all your doubts, and in detail, in depth, all concepts will be taught to you. And I hope I think all of you that is all of you definitely gained some knowledge related to that is physical properties of metals and non-metals. Thank you, students.